All right, once we have these solubility rules that we talked about with the first question here, once we have those under our belt, we can use those to figure out and understand precipitation reactions. So I'll go through and show you guys step by step how I work one of these precipitation reactions. So I take the two reactants that are given, and they're both aqueous. They have to be for these. They have to be dissolved in water. And then I assign the charges first. And I put, here I've put 2 pluses for the 2 potassiums. Each potassium has a 1 plus charge. The sulfate has a 2 minus charge, and then the nitrate has a -1 charge. And I want to know what those ions are because I'm going to switch them around now. So I put the silver first, and that's just a system that I like to do, is leave the metals alone. I put the silver first. I put the potassium second, and then they switch partners. So silver was with nitrate, silver now is with sulfate. Potassium was with sulfate, and now it's with nitrate. Some of the times after I've done this, I need to fix a formula, and here's a case of that. And here's why it was nice for us to have our charges already. So silver +1, sulfate 2 minus. The compounds at the end have to be neutral, so I need to double the amount of silvers. So 2 silver pluses, and now 1 SO4 2 minus gives me a neutral compound. This one's already okay, potassium plus and nitrate minus. So now I have 2 compounds, and I use the solubility rules. So this is silver sulfate. Sulfate salts are usually soluble. However, silver sulfate is an exception. So silver sulfate is insoluble. That means it gets an S. It precipitates out of the solution as a solid. The other one that I have here, potassium nitrate. So all nitrate salts are soluble, and all potassium salts are soluble. So this is actually a really soluble compound. So it stays into the solution. Okay, after that, I need to balance everything. So this has 2 silvers. So far I've only committed to 1, so I put a 2 there to balance the silvers. I have 2 potassiums. I have only 1 over there, so I double the amount of potassiums. And now I'll just put 1 so that you know that I've also looked at those. This is now a balanced molecular equation. Okay, that's what we call this, that has it written out like you would be used to saying a reactant, another reactant, what state they're in. Both these are dissolved in solution, precipitating out a solid product, and then one of the other products staying in solution. So next I do this, what's called a complete ionic equation. And I go up here, and anything that's written as aqueous, I write it as separate ions. That's applying the knowledge that when any ionic compound dissolves in water, it does so by coming apart into its ions. So 2 silver plus aqueous plus 2 nitrates aqueous. So 2 silvers and 2 nitrates. 2 potassiums. But you see, I get to my 2 a different way here. It was 2 out front, 2 silvers, and now it's a subscript 2. Still, I got 2 potassiums aqueous, and I have a sulfate aqueous. Okay, now on my product side. So neither the silver nor the sulfate is dissolved in solution anymore. It has precipitated out. So I write this as Ag2SO4 solid. Okay, not as separated ions because it's not. It's sitting at the bottom of the beaker, bottom of the flask as a solid now. And now for the second part, 2 potassiums aqueous, 2 nitrates aqueous. Okay, now I do what's a net ionic equation. And you may notice that nitrate is both a reactant and a product, and potassium is both a reactant and a product. Something that appears identically as a reactant and a product, I can cancel out, and now my net ionic equation, 2 silvers aqueous, plus a sulfate aqueous gives me Ag2SO4 solid. And that's my net ionic equation for 2A.